A crane can meet the stated hook load and still be wrong for the vessel. Longer outreach may reduce available capacity, vessel motion may increase practical demand, the foundation may not carry the resulting loads, and the boom may interfere with rails, hatch covers, containers, or access routes. Selection must begin with the complete lifting task, not a nominal capacity figure. Define the cargo, normal and occasional maximum loads, foreseeable off-normal lifts, handling frequency, lift path, operating location, sea state assumptions, installation zone, and control responsibility. Different duties create different demands. Compact maintenance equipment lifted near the vessel side does not impose the same geometry, visibility, precision, or operating conditions as stores handled across a wider radius. Dynamic effects also matter. Vessel movement, suspended load swing, acceleration, wind, and off-lead loading can increase demand on both the crane and its mounting. A load chart is useful only when its assumptions and restrictions are understood. The proposed duty must be tied to a defined service, whether harbor handling, offshore support, maintenance, or another operation requiring project-specific engineering or approval. Outreach should be mapped from the crane centerline to every required hook position on the actual deck plan. The assessment must include cargo landing points, rail geometry, access routes, obstructions, and boom stowage. A longer boom may appear to offer flexibility, but it can change capacity, foundation loads, visibility, hydraulic response, and stowage requirements. The controlling question is where the hook must travel safely under real operating conditions. Mounting position links that geometry directly to vessel structure. Verify slough clearance, maintenance access, hose and cable routing, local reinforcement, and the load path through the foundation. Current general arrangement drawings and structural information should reflect corrosion, previous modifications, legacy equipment, and restrictions on welding or deck penetrations. Foundation loads for the final configuration must then be reviewed by the responsible vessel design, class, project, or engineering authority, with clear ownership of calculations and document revisions. The surrounding operating envelope needs equal attention. Operators require sightlines to the load, defined communication methods, and clearly controlled exclusion zones. Vessel stability, cargo staging, and changes to the normal lift route must be considered in lifting plans, operating instructions, and commissioning records. Hydraulic integration is a system check, not a visual match with an existing crane. Confirm pressure, flow, motor displacement, valve arrangement, filtration, reservoir condition, heat rejection, return line restrictions, contamination control, and hose routing. Establish whether the crane has a dedicated power pack or uses the vessel system. Replacement components must be verified by part number, mounting interface, pressure and flow requirements, shaft and flange arrangement, control configuration, and revision status. Electrical and control interfaces require the same discipline. Control stations, remote options, alarms, interlocks, emergency stops, communications, brakes, selector switches, and vessel monitoring connections should be defined before fabrication or installation. The technical package must distinguish crane supply from vessel scope and identify the tests that will demonstrate completed safety functions. Before commercial comparison, treat required load at radius, foundation suitability, operating limits, and applicable approvals as critical gates. Then assess boom geometry, hydraulic and electrical interfaces, control layout, and service access. Finally, confirm lifecycle readiness through inspection plans, critical spares, support arrangements, and controlled records. Each gate should be marked verified, pending, not applicable, or outside supplier scope. Quotations become comparable only when radius, duty, controls, interfaces, exclusions, documentation, and commissioning assumptions are aligned. At handover, retain drawings, limitations, hydraulic and electrical data, inspection evidence, commissioning results, fitted component details, approved alternatives, and installation deviations. That configuration record preserves the evidence needed for maintenance, replacement, and future change.